Today, we're going to add specular highlights to our Toon shader. Let's go! For the last couple of weeks, we've been working on a Toon shader. 2 weeks ago, we created a shader that created the paint effects. And last week, we talked about how to create the dark ink outlines. Now, we're going to add the specular reflections to our shader. This is a completely optional step. You can get along just fine with a shader that just has the paint and the dark outlines. But if you want to add some additional pop to your Toon effect, adding specular will do it for you. A specular highlight is a reflection of the light source in the scene. This is an effect that game engines usually handle for you. So you just pass in the base color, the metallic, the specular, and the roughness. And then under the hood, the game engine calculates the specular and renders it. But in our case, we're starting with an unlit shader, which means the engine is not handling these things for us, and we have to do it ourselves. So I'm going to show you two different methods for creating specular today, Blinn and Phong. And we'll talk about some variations in the ways that you can handle them. All right, so let's jump in and start creating some cool Blinn and Phong specular highlights. So here's the shader where we left off when we were creating our outlines last week. And the first thing that we need to do to be able to create a Blinn specular highlight is create a half angle. And to create a half angle, first of all, we need the direction of the light source. And then we also need the camera vector. And what we're doing with these two is we're creating a vector that's halfway in between the light source and the camera. So the way that I'm going to do this is I'm going to add these two vectors together. Right now we have a camera vector that's going from our eye to the surface of the model, and we have a light vector that's going from the light to the surface of the model, and we're going to find an angle that is halfway in between those two. So to do that, we add the camera and the light vector together. Then we normalize the result. And that gives us our half angle. Now we're going to do a dot product between our half angle and the normal of our surface. And so already we're making really good progress. Let's take a look and see what the result of this operation is. I'm just going to plug it right into the emissive socket on my root node here. You can see as I'm turning this around, the closer I am to looking at the surface or lining up my view with the light source, the larger this effect is, and then the further away, the more it shrinks into a little pinpoint. That's creating kind of some weird effects, and so what we need to do to get rid of this junk on the opposite side, we only want it to be on the light side, not on the dark side over here. And so what I'm going to do is saturate my result. And this will clamp everything between 0 and 1. And then I'm going to raise my result to a power. So I'm going to create a power node here. And here, this exponent here will control how sharp, how narrow and focused our specular highlight is, or how broad and unfocused it is. So in this case, I'm going to lay down a float parameter, and then I'm going to right click on it and pick convert to parameter. And we're going to name this parameter spec focus. Could also call it spec power, some people do. And then I'm going to give it a default value of something like 32. So I'll wire that into the exponent of my power node. Let's see what results we get from this. Okay, now you can see that we have something that nicely resembles specular power. So as I face toward the light, the specular highlight is nice and centered, but then as I face away, you can see that it kind of follows the camera and the light source. And that's what this half angle calculation is doing here. So we've created this vector that's, again, halfway between the camera and the light source. And then we normalize that and we compare the angle of that vector with the surface normal, and then raise it to a power to kind of control how tightly focused or broad it is. So I can change this specular focus value. If I set it to something like 512, you'll see that I get a really tight specular highlight. But if I set it to something really small, like 4, for example, I'm going to get a really broad specular highlight. Okay, so that is basically the Blinn formula. And the question that we need to answer now is, what do we do with this, or how do we integrate it in with the rest of the shader? Well, there's two really good ways of doing this. One is to add it in right here in between our gradient sample and our color multiply. So let's do that first. I'm just going to take the results of my Blinn here and do an add. And we're going to add it to the results of our texture gradient. And then we're going to pass that into our multiply here where we multiply in our final color. And let's take a look at what we get. So this is looking pretty decent, but it's kind of broad. So let me sharpen this up again so you can see a little bit better what's happening. Because I've added it to our gradient and then done the multiply after, our specular highlight is getting colored by the same color that we're coloring our paint with. And it's getting toned down a little bit so you can barely see it. And so one last thing that I may want to do is add in another multiply here. And I'm going to multiply it by another parameter. So again, I'm going to hold down the 1 key and click to add a float parameter. And then I'm going to right click on this one and do convert to parameter. And we're going to name this one Spec Brightness, because we can use this multiply to control how bright our specular is. So if I give this a value of something like 4, we're multiplying our result now by 4 before we pass it in, and that's going to make our specular highlight really pop out. Okay, so you can see that we have a specular highlight now that's not pure white, but it's actually tinted by the color value here that we're using to also tint our paint. So that helps to blend the specular highlight in with the paint color that we're already using. However, there is another way that we could do this. We could add in our specular highlight after our paint color multiply. If we know we want our specular highlight to always be white and not tinted by the same paint color, we can add it in after this multiply. So I'm just going to wire the result of my texture sample into multiply, and then I'm going to wire the output from the multiply into this add, and then reconnect it like that. Now our specular highlight is not being tinted at all by the color that we're using for our paint, and it's just staying this nice bright white color. So those are two alternatives. If I want to use that alternative, I probably want to turn my specular brightness back down to something like 1, unless I want to have an effect where it's super cranked like that. Another thing that I could do is this specular highlight doesn't really match the same style as my paint outlines do here, where they have these nice tight edges. So if I wanted a specular highlight with a precise tight edge, I could add a round node here at the end so that it's going to round up to 1 or round down to 0, and then add that in, and that's going to give me a specular highlight with a nice tight edge. That might be the style that you're going for as well, so you could do that. Or if you wanted to make your highlight a little bit softer, a little bit less painty, and maybe a little bit more stylized, you can skip the round and make it nice and soft like this. Okay, so I'm going to select these nodes here, and I'm going to add a comment here. I'm going to call this Blinn, because these nodes are creating the Blinn function. This is also one method for creating specular that can be done inside the engine. Most engines nowadays use more PBR-friendly specular methods, like GGX, for example. But in our case, today we're just doing the Blinn calculation for specular highlights. Okay, the other method for doing this is called the Phong method. And it's just a slight variation on Blinn. And by the way, the reason these are called Blinn and Phong are because the people that invented them were named that. So this is named Blinn because Jim Blinn came up with this formula. And the Phong specular highlight formula is named after somebody named Phong. All right, so to do the Phong method, we're going to be creating a reflection vector. So I'm going to go for a custom reflection vector node. And we're going to plug in the pixel normal into the normal socket. And it says here camera vector, but instead of using the camera vector, we're going to be using the light vector because we want to figure out the reflection vector of the normal and the light source. Because basically what a specular is a reflection of the light. And so here we have that relationship here. We're reflecting the normal and the light source. And then we're going to do a dot product between that and our camera vector. So here's our camera vector, connect up the dot product, and then we're going to saturate the result. So let's take a look at what we get with this. Yeah, so as you can see, I've got kind of a specular highlight going on here. And as we rotate around to the edge, the highlight kind of spreads out and fills the edges. But this one is a little bit too big. So just like we did with the Blinn version, we also need to do a power. We need to raise this to a power. So I'm going to add a pow node. And we're going to use this same spec focus param that we used before. So I'm raising my result to a power of 32. And then we can also multiply our result by our specular brightness. So there's our multiply by our specular brightness. And let's rejigger this back to the way that we had it before because I really like adding this to our texture sample, our gradient, and then multiplying it by the color afterwards. I prefer that method. Okay, and let's wire this in here. And then now we're going to use our Phong specular instead of our Blinn specular. And there we go. And just like with Blinn, this is a little bit dim. So we need to increase our brightness to something like 4, maybe even 8. Okay, so there we have a Phong specular highlight. Now, one thing that's different about the way that Phong behaves, and this is a little bit more realistic, is that as the specular gets to the edge of the model, it spreads itself out and does a little bit of rim lighting along the edge of the model. So that's a little bit more realistic than the Blinn version. And just like with Blinn, we can also add a round node in here. If I wire in the round and then connect that up, I'll end up with a specular highlight that, ooh, that's interesting. Because I'm multiplying by 8, I actually get multiple levels of rounding, and that's a really interesting effect. You might want to go with that. But if not, you can always turn down your specular brightness to 1, and it's just going to give you a nice little hard-edged specular dot. You could use these for something like Toon eyes, for example, that have nice little highlights in them. Okay, cool. So we've taken a look at 2 methods of creating specular highlights in your Toon shader. Let's go ahead and group this here. Create comment from selection, and we're going to call this the Phong method. And so you can do either of these methods with or without a round, and you can add them in before or after you multiply by your color, just depending on the effect that you're looking for. So lots of different methods of doing specular highlight. You can control all of your own lighting here, which gives you a lot of control over the final look that you're going for. Lots of different choices, and you're able to really dial in and control your own style for your Toon shading. So pretty cool. Let's switch over to Unity and take a look at how to create the same effects there. Okay, so here we are in Unity, and you can see we've taken up the shader exactly where we left it last week, where we added our nice Toon paint outlines. And if I scroll up here, you can see that I've already created our Blinn effect. I've got my main light direction node here, and my camera, which brings in lots of camera parameters, but in this case, I'm just using the camera direction. Now, in the case of Unity, I'm negating both the main light direction and the camera direction before I add them together, so that my specular highlight will be oriented in the proper direction. Then I normalize the result of that add, and then I do a dot product between my half angle here and my normal vector. Then I saturate the result and raise the result to a power. In this case, I've given it a value of 16. If I wanted to, I could open up my blackboard here and add a specular focus and specular brightness values and wire them in. In fact, I'm going to go ahead and do that. So I'm just going to add a float value here, and we'll call this spec focus. And we'll add another one and call this spec brightness. Then I'll drag those into my shader, and we'll wire that into the power. And then for the brightness, we'll wire this one in for our multiply here. Now I need to give these default values, which means I'm going to open up my graph inspector. For my specular focus, I'll give it a default value of, say, 32. And then for the brightness, I think I saw that I was needing a brightness value of something like 0.7. So I'll just make that the default. And now I'm going to connect up my Blinn here. And I want to connect them right here to my gradient before I multiply it by the color. So let's put in an add node here and add in our Blinn specular. And now you can see, you know, there is a difference here in Unity, and that is Unity's color values are clamped. And so if I go above 1, it's just going to clamp it and not give me a very nice looking result here. So what I'm going to do instead of adding my specular in here after the gradient is I'm just going to wire my specular values directly into emissive. So I'm going to take my Toon paint values here, and I'm going to wire those into my base color instead of emissive. And then I'm going to take my specular values here and wire those into my emissive. And this way I'm going to get a specular that's brighter and not quite as clamped or blended in with the paint values here. So now I get a value that goes all the way up to white instead of being clamped like it was before. Okay, now I can take my specular focus and I can dial this in. If I want to have a really broad specular highlight, I can turn that down. If I want to have a really sharp, tight dot specular highlight, I can turn it way up to something like 512. Or again, like I did in Unreal, I can add a round node. And this will round it and make the specular highlight perfectly sharp. If that's the case, I probably don't want to focus as high as 512. Maybe I want a little bit larger specular highlights, so I'll turn my focus down to 32. Anyway, so that's how Blinn works. And I've also got Phong in my scene here, so if I zoom in, you can see I'm doing the reflection vector between my main light direction and my normal vector. Then I do a dot product between that, which is calculating my reflection vector. So I'm doing a dot product between my reflection vector and my camera direction. In this case, I need to negate my camera direction to flip it in the opposite direction. Then I saturate the result and raise it to a power. And this power is my specular focus, so I can wire this specular focus parameter in there. And then I multiply it by a value here, which is my specular brightness. So I can connect up my specular brightness parameter there. Now I can wire my Phong specular highlight into my emission. And now I've got a Phong specular highlight instead of a Blinn specular. Now, if I wanted to go really crazy, I could add both of these together. So I'm doing both Phong and Blinn. This is crazy. I wasn't actually planning to do this, but it just occurred to me just now. So let's see what happens. We're going to have a Phong highlight and a Blinn highlight. So let's wire this into our emissive. And I guess they're both in the same place, so you don't really see it. Maybe if we tried this in Unreal and we could rotate our sphere around, the behavior of that highlight would be a little bit different. But in this case, they're just right on top of each other, so you don't actually see a difference. Oh well. Anyway, I hope you enjoyed this video and that it showed you the basics of doing specular highlights. As I said at the beginning, this is a completely optional step, and it just adds a little bit of pop to your Toon shader. Whereas before you just have plain paint and then the ink outlines. Now you got a nice highlight to really make things pop out for you. So we talked about Phong and Blinn and how specular is normally calculated under the hood in the engine. But if you're doing an unlit version of the shader, you need to calculate the specular yourself. And here are two ways that you can do that. Cool. Well, be sure to come back next week because we'll have more shadery goodness to show off. And in the meantime, have a great week, everybody.